Alright everyone, I'm going to be doing problem 2.39 for you guys today. Basically this problem says that there are two spherical cavities of radii A and B, which are shown right here, and they're hollowed out from the interior of a neutral conducting sphere of radius r, basically the big circle right there. At the center of each cavity a point charge is placed, call these charges QA and QB, that's those two. Part A wants us to find the surface charge densities. So that's pretty easy because they're each just, the surface charge density is the charge of each one over the surface area. Basically the only thing that's changing between these is the radius. So with sigma A you're going to have negative q sub A over 4 pi a squared. Sigma sub B you're going to have negative q sub B over 4 pi b squared. And then with sigma sub R, basically because there's an induction that's occurring on the sphere, so both of QA and QB, the cavities in the sphere, are induced charges. Basically there's like a negative charge that's created on QA and QB because of the induction rod, then that creates a positive charge on the actual surface of the sphere. The sigma sub R is going to have Q sub A added with Q sub B, and that's over 4 pi big R squared. Alright, for part B, it says what is the field outside the conductor. Basically that's just going to be, we're treating the whole thing as a point charge again to find the electric field. So for E outside it's going to be Q sub A plus Q sub B over 4 pi epsilon naught R squared, and that's because we're using the whole sphere and treating it as a point charge, so we're using that sigma sub R charge density. For part C, it wants the field within each cavity, which is going to be E sub A and E sub B. Those are both pretty easy because then you just treat Q sub A and Q sub B as point charges. You just use that charge, so you use Q sub A over 4 pi epsilon naught R squared, and then QB over 4 pi epsilon naught R squared. Alright, part D is what is the force on Q sub A and Q sub B. Both of Q sub A and Q sub B experience zero force, and that's because they're both point charges and they're stationary. Also, through the induction, the electric field created around them basically cancels out in a way that there's no actual force created on the point charges. Then part E says which of these answers would change if a third charge QC was brought to the conductor. Basically the cavities are kind of independent in this problem, so the only thing that would really change is the sigma sub R and the E outside. So sigma sub A and sigma sub B would both be the same, and then you'd have in the sigma sub R the plus QC right there that would also influence the overall electric field and the charge density. So then for the E outside you would also have Q sub A plus Q sub B plus Q sub C. But those are the only two things that would change, and there still wouldn't be any forces on the actual cavities. So that wraps up the problem. Thank you.